Here we go, Math 3, Practice 2A.3.3, so finding some zeros. Alright, so on these first set, they want us to, they've given us one of the roots, so they want us to determine the number and type of roots for each equation. Then we got to find each root. Okay, so basically find the roots. Now, a few rules to remember. Okay, so first of all, the fundamental theorem of algebra. Okay, which basically tells us if we have a degree bigger than 1 or equal to 1, okay, with complex coefficients, then the related equation p of x equals 0 has at least one complex solution. Okay, one. So that's really basically the fundamental theorem of algebra tells us that if we look at the powers, okay, that we could have, we'll have 3 roots. Depending on the highest degree, that tells us how many roots we have. So down here at 4, we've got 2 roots, okay, 2 zeros, 2 x-intercepts. Now, those zeros and x-intercepts can be either real or complex. Complex has the imaginary numbers in it. Okay, the I, or square root of -1 as it is. Okay, or just real. So there can be any sort of combination of real and complex roots. Now, there's one thing to note about complex roots. Okay, is this, that if you have a complex root, so say 2 plus 3i, okay, then its conjugate is also a root. Okay, so 2 minus 3i would also be a root, because with imaginaries they basically come in twos, the positive and the negative version. So if I have 3i, then I also know I have negative 3i as a root. Okay, so looking back here with 3, I could have 3 real roots, or 3 zeros, real zeros, or I could have 1 real zero and 2 complex. I could never have 2 real and 1 complex. You always have to have 2 or 4 or 6 complex. Okay. So also we've kind of done this with synthetic division, but the idea is if you have a remainder of 0, okay, then you're going to get that as a factor, okay, which in essence is a 0 as well. Okay, and then the last one, if the coefficients of a polynomial function are integers such as a to the n equals 1, a to the 0 equals 0, then any rational zeros of the function must be factors of a sub 0. Okay, rational would be with the roots in there, square root, cube root, and that stuff. So that it would have to be basically the y-intercept as well, right? A sub 0, that first term. Okay, that one we don't see as much. Alright, anyway, let's get going. So on these first ones, they've given us a root and the function. Okay, they want us to find each root. Now, there could be 3 on all of these because they're cubic, but we don't know what type. Okay, so the way we can do this is we can simplify it using that synthetic division. That's what we want to do. So that would be like 1, -7, and 6. So remember, bring down the 1, then 1 times 1, take it up here, 1, -7 plus 1, -6, -1 times 6, -6, 6 plus 6 is 0. Okay, so now what that tells us is that gives us our factor. Basically this 1, x minus 1, is one of our factors, okay, if we were to factor this out. And then if you solved that for 0, you get a root of 1. Okay, so we know we have at least 1 real here. Now, if you recall, this was cube, so this 1 would be 1x squared, then minus 6. Okay, that's our other factor. Now, can we simplify this one? Kind of. The best thing to do would be to then split these up. Okay, and we find the zeros, the x-intercepts. So we knew 1 was already 1. Second one, x squared minus 6 equals 0. So we'd add 6 to both sides. We get x squared equals 6. Take the square root of that, and we get x equals the positive or negative version of the square root of 6. Okay, so that would also be a real root, but a irrational root. So we have 3 real, 1 rational, 2 irrational. And what are those roots? Well, x equals 1 and negative square root of 6 and positive square root of 6. Those are our 3 roots. Okay? Alright, let's take a look at number 2 now. So number 2, same idea. So we start with synthetic division to simplify. So I've got 1, negative 3, 25, and 29. Okay, I know this is one of my roots. So my roots are, or my zeros are, negative 1. And then I've got to find 2 more, right? They could be real, they could be imaginary. And for real roots, remember we have rational, which are just like regular integers and numbers. Irrationals, which would be square roots that aren't like the square root of 16, which is really 4. Okay? So, first synthetic division. Bring down to 1. Negative 1 times 1 gives us negative 1. Add them together, we get negative 4. Negative 1 times negative 4 is positive 4. Add them together, we get 29. Negative 1 times 29 is negative 29. Add it, and we get 0. Okay? So when we simplify this to x squared minus 4x plus 29. Okay? And we made a mistake on the first one, didn't we? I just realized it. What did I do? I forgot the x squared term. I forgot that we had to do that. So we'll have to go back and fix that one. Good thing I caught it though. Okay, now we know that x plus 1, because it's negative 1, is 1 factor times these. Okay, well now we can simplify this factor. We really don't need to worry about that one, because we already know that it's going to be one of our zeros. Now, can we factor this out further? So think back to that area model, and we can think, is there anything that we can multiply 29 by and get that to be a negative 4? And I can't think of anything, so we need to rely on the Pythagorean, or not Pythagorean, the quadratic formula, which looks like this. Opposite of b plus or minus square root of b squared minus 4 times a times c over 2a. A would be the number in front of x, so a is 1. B would be negative 4. And c would be 29. Okay, so I put that in. So b becomes negative 4. So negative 4. Negative 4 squared. Then a and c. A is 1, c is 29. And then 2 times a, which is 1. So negative 4 becomes positive 4 plus or minus the square root of negative 4 squared is 16 minus 4 times 1 times 29, which is 116, over 2 times 1, which is 2. Then we simplify this further. Let me grab a calculator. Oh, or not, because that would be easy. 16 minus 116 is negative 100. 4 plus or minus negative 100, square root of negative 100 over 2. Square rooting a negative should tell us right off the bat that's like the square root of 100 times the square root of negative 1. That is I. This is 10. So we get 4 plus or minus 10i over 2. Then 2 can go into 4 and 10, so we get 2 plus or minus 5i. So that's 2 imaginary roots. Okay? So we have 1 real and 2 imaginary. Because 2 plus 10i and 2 minus 10i. Okay, now we need to go back and fix number 1, don't we? So we should have went 1, then I should have went 1, 0, negative 7, and 6. Let's see how that changes things. That would give us 1, add, this actually is going to be the same, isn't it? So it did work out, but for the wrong reason. Yeah. So we'd actually end up with, no, so it would be different. So we'd have x squared plus x, that represents those two, minus 6. Okay, then we say, can I factor those? And it would factor, right? Because negative 2 times positive 3 would be negative 6. Added would be 1. So I'd get x minus 2 times x plus 3 times my x minus 1 from the beginning. So we actually have 3 real roots here. And they would be 1, 2, and negative 3. Sorry that I led you on a goose chase on that first one, but I'm glad we fixed it. Okay, number 3. So 3 here. Synthetic division, 1, negative 4, negative 3, and 18. Bring down to 1. 3, add it, negative 1. Negative 3, add it, negative 6. Negative 18, add it, 0. So we get x squared minus x minus 6. So this one was just kind of like number 1, wasn't it? Except we have x minus 3. So factoring that, a negative 6, but a negative 1 would be negative 3, positive 2. So x minus 3, x plus 3, and x minus 2. Then if you set them all equal to 0 separately, you just end up getting the opposites, right? So we have positive 3, negative 3, and positive 2. So negative 3, 2, and 3 for our zeros, our x-intercepts, which are 3 real ones. Okay? Now, 4, 5, and 6, they want us to graph them and to find all the zeros of the function. Okay? And they want us to graph to verify. Alright. So if we're going to graph it, that makes life a lot easier for the most part. Okay? So looking at number 4, it's got a 2. I know there's going to be 2 zeros here. So let's graph it. So I used Desmos, which is an excellent graphing tool. Please use it. And here we get our graph. Okay, so if we look at this graph, we can see crosses the x-axis at 2, 0 and negative 6, 0. So in other words, if we would factor this, it would be x plus 6 times x minus 2. So we have 2 zeros, they're both real, and it's negative 6 and positive 2. Easy enough when we graph it, right? Alright, so taking a look at number 5. Okay, 5, we've got a cube, so we know we're going to have 3 zeros. Okay, and they could be 1 real with 2 complex, 3 reals, or 3 reals that are rational or 3 that are irrational. Okay, so let's graph the second one now. So here's our second graph. Okay, now notice we should have 3 roots, or 3 zeros. Okay, or 3 x-intercepts. We've only got 1 showing up. Okay, that means that our other 2 are going to be imaginary because they won't show up on a regular graph. So we can use what we did in the first 3 to figure out the other 2. But we know 1 is going to be negative 1, so we know if we have a factor of x plus 2, no, x plus 1. I'm off it today, aren't I? So we can think of this kind of like we did up here. Okay, so we know we've got that negative 1 is one of our roots. So using synthetic division, we can figure this out. So bring down to 1, that's negative 1, add it, negative 4. That's a positive 4, add it, that's 5, negative 5, so 0. So we get, as factors, x plus 1, which was the one we knew, then x squared minus 4x plus 5. So, can we factor that one further? Well, factors of positive 5 that would equal negative 4, there aren't any, are there? So we use the quadratic formula. So a is 1, b is negative 4, c is 5. So I'd go negative negative 4 plus or minus the square root of negative 4 squared minus 4 times a times c over 2 times a. So positive 4 plus or minus square root of 16 minus 4 times 5 times 1 is 20 over 2. 16 minus 20 is negative 4. You can probably see where this one's going. Okay. think of negative 4 as square root of 4 times square root of negative 1. This becomes I. This becomes plus or minus 2. So we get 4 plus or minus 2I over 2. 2 goes into each, so 2 plus or minus I, because it'd be 1I. So there's our other 2. So 1, and then 2 plus I, and then 2 minus I. So 1 real, 2 imaginary. Okay? And that's why we need to be able to figure it out by hand, because graphing won't tell you the imaginary ones. Okay, let's do number 6 now. So number 6, same idea. Let's graph it. Okay, so here's our graph. We know we should have 3 roots, and we can see them all, right? Negative 2, so that's as a factor is x plus 2. Positive 1, that'd be x minus 1. And positive 5, x minus 5. So if we were to take and factor this out, we'd end up with these factors, which are these roots. Okay, so negative 2, 1, and 5. So 3 real roots. Okay, now 7 and 8 want us actually going backwards. Okay, they're giving us the roots. They want us to write a polynomial function. Okay, the simplest one we could. So the first step is to take each one of these and turn them into a factor. That would be like saying x equals negative 5. Well, make this, add 5 to both sides, and you'd have x plus 5 equals 0, and that would make it a factor. So just go x, then the opposite. Negative 5 becomes plus 5, times, and this is going to equal our function, negative 1, so it would be x plus 1, the opposite. Positive 3 would be x minus 3. Positive 7 would be x minus 7. Okay, now we need to multiply these guys. So let's give us a spot to do that. And we're just going to use that area model to multiply things out. So let's do it twice. First, so x plus 5, x plus 1, right? Then we'll do our second one, x minus 7, x minus 3. Yep. Let's solve these. So we get x squared, 1x, 5x, and 5. So x squared plus 6x, because we combine like terms, plus 5. So we're just multiplying. Then x squared, negative 7x, negative 3x, so negative 10x, right? X squared minus 10x. And then positive 21, plus 21. Now we're going to do it one more time with these guys. So x squared, 6x, 5, x squared, negative 10x, and 21. And this is going to give us our equation, essentially. So x to the 4th, which makes sense, it's the biggest because we have 4 roots. 6x cubed, 5x squared, negative 10x cubed, negative 60x squared, negative 50x, 21x squared, 126x, and 105. Okay, then combining like terms that are like, x to the 4th, it's positive 6, negative 10, negative 4x cubed. 5 and 21 would make 26, minus 60 would be 34, minus 34x squared, right? I've already made enough mistakes, so I should probably fix that, yeah. Then 126 minus 50 would be 76x plus 105. And that's our equation. Okay, that's the answer for number 2. When you multiply those out, we get x to the 4th, so our function equals x to the 4th minus 4x cubed minus 34x squared plus 76x, right? Plus 105. So now, for 8, we're going to do the same thing. The thing is, we've got to remember that conjugate rule. So if I have a positive version, so I have x minus 4 for my first one, then I'm going to have x plus 2 plus 3i. But then I have to have the conjugate version, so x minus, actually, x plus 2 minus 3i. Right? Hold on, let me think this one through. I always forget on these ones. We'd have to subtract them both, so it would be x minus 2 minus 3i. If that were a minus, that would be plus. Okay, so minus on these, and then the rest is good. Alright, so once again, we're going to have to multiply these out. So let's give ourselves some space. Okay, and we'll start off with these guys because they're uglier. Okay, so here's all our factors again. So, use the area model. Let's multiply out. So x, negative 2, negative 3i. X, negative 2, positive 3i. So x squared, negative 2x, negative 3xi, negative 2x, positive 4, positive 6i, positive 3xi, negative 6i, and negative 9i squared. Now here's the beauty with this. Okay, positive 3xi, negative 3xi, they cancel. Negative 6i, positive 6i, they cancel. I squared is really negative 1, so that becomes positive 9. Okay, so those two combine and these two combine. So we get x squared minus 4x plus 9 multiplied by x minus 4. So we do the area model one more time, and that's going to get us our stuff. X squared, negative 4x, 9x, negative 4. So we get x cubed, negative 4x squared, 9x, negative 4x squared, 16x, and negative 36. So x cubed minus 8x squared plus 25x minus 36, and there's our equation for number 8. Okay, it would be that. Alright, so now let's just take a look at number 9 and number 10. Alright, so the last two, 9 and 10, we are using the story problem. So a portable fuel tank used to transport gasoline is in the shape of a rectangular prism. Okay, oops. Don't know where that appeared from again. There we go. So, taking a look at this, okay, draw the picture out, that can often help. So I've got this rectangular prism here, right? I don't like my rectangular prism because I need to make this side a little longer. Okay. Now it says the tank is 5 feet longer than it is wide and 29 feet deeper than it is wide. So the wide we'll call x. Okay. So it's 5 feet longer, so it'd be x plus 5, and 29 feet deeper than it is wide. So the depth here would be x plus 29. The volume of the tank is 33,488 cubic feet. So it says, what equation represents the volume of the portable fuel tank? Well, volume of a rectangular prisoner is length times width times depth. So we'd go x times x plus 5 times x plus 29. Okay. Now we could multiply that out, right? However, don't get number 10, use synthetic division to find all the roots of the polynomial equation. We've got all the roots right here. Okay? So I don't understand why they want us to use synthetic division to do this. Because basically, x equals 0, x plus 5 equals 0, and x plus 29 equals 0. So it would be 0 would be one root, one x-intercept. Subtract 5, negative 5 would be another, and then negative 29 would be the third. Okay. But that doesn't make sense either, does it? Because that really wouldn't work in order to, negative numbers when we're dealing with volume doesn't really make sense. So what more do we need here? So maybe they want us to do some other work. No, that's what it would look like to me. Well, let's keep going with this. So this would be our roots. Okay. What are the dimensions of the fuel tank? So in order to figure it out, we just set that all equal to 33,488, and then we would solve for that. Okay, which that is going to prove to be more difficult. Okay, but let's find our equation. So to find our equation, we're going to need to multiply here. So let's clear some space. So we have x plus 29. So, and then we've got x and positive 5, right? So we get x squared, 29x, 5x, and then 29 times 5, 145. So, would be x squared plus 34x plus 145 would be our equation, right? Okay, just like that. Oh, we forgot to multiply by that last x, didn't we? So basically that would make that x cubed, 34x squared, and 145x. Just kind of adds an x to everything, right? So that would be cubed, squared, x. That would be our equation. Okay? So we've got our equation, we've got our zeros, our roots. Now we just need to figure out what the dimensions of the fuel tank are. Okay? So to figure that out, this is what we're going to have to do. Alright, so basically we'd set up the equation, okay? Let me clear some space so we have some room. So we've got our volume, okay, that's going to be equal to our equation. So we've got x cubed plus 34x squared plus 145, or 146, 145x. Okay, so what we need to do is get this number, we'd subtract it from both sides. So we'd end up with 0 equals x cubed plus 34x squared plus 145x minus this. Now, we could try to do synthetic division, but we don't know what one of our roots are. Okay, so that's not going to work because we want to figure out what x is going to be equal to. So the easiest thing for us to do is to actually graph this. Okay, and let's see what our graph looks like. So here's our graph. Now notice my x values only go up to 40 and down to negative 60, but look how big my y values are because that's such a big number. Okay, so what we should notice here is a few things. First, we should have 3 roots, right? Since our whole thing's equal to 0, we're solving for x, okay? Because our width is going to be x. So we look at this, and our width, okay, the only one that crosses, we only have one real 0. The rest are imaginary. So the only one possible answer is 23. So our width is 23, okay? So if our width is 23, add 5 to that, that gives us our length. Add 29 to that, and that gives us our depth. And there we go.